Hello. Thanks for being here. We are going to talk about automating your AI journey. Do a quick intro here, and then we'll get started. Sujith?
Hello, I'm Sujit Joseph. I work as a principal engineer in the Cisco AI and Automation Center team in the Cisco Operations Group. We provide Gen AI services to broader teams across Cisco, and we also own an AI assistant on a circuit, which I'll talk more about.
Very good. So Sujith will be back with us here shortly. I'm going to get us kicked off. My name is Shannon McFarland. I lead the Cisco DevNet organization, so we're right down the hallway. So if you are into learning hands-on programmability, APIs, a lot of the things that we're going to talk about in here through this 30-minute session, we'll be able to actually provide you hands-on stuff over there. I also lead the OSPO, or Open Source Program Office, which is basically anything related to open source in or out of Cisco is something that my team handles. So I'm going to kick us off here in kind of describing what our problem statement is. It's going to resonate well with everybody because the problem statement we're talking about predated anything that we're doing with AI. So it's going to resonate well, but we'll actually work through how we can actually gently introduce AI into your brownfield ops environment. And then Sujith will come back up and talk about a cloud-native, AI-first greenfield implementation that they've done within Cisco. So we're going to have this WebEx app available for you for questions. Sujith and I will be right over here after the session. But if through this session or later in the week you think of a question for us, please hit us in this WebEx space. Also in the very final slide that we have, Sujith will walk you through kind of where we're located. Again, DevNet zone over here, and he'll be over at the actual circuit booth as well. So please remind yourself later on if you got a question for this. So we did intros. I'm going to talk a little bit about kind of a level set of AI infrastructure complexity, and then we'll get into kind of a gentle introduction of AI to get you towards an AI first ops journey. And then again, Sujith will be talking through our use case. So these complexity demands predate anything that we're doing with AI, right? We're always in a hurry. Especially on the operations side and the development side, we're in a hurry to get things built and deployed as best we can. And so we've done that through rethinking the way we do designs and the way that we templatize config files, and that we really try to produce a nice starting model for the way we're introducing any kind of development or operational cycle. And that really came from the onset of continuous integration, continuous deployment, infrastructure as code pipelines, again, all trying to get the efficiency of speed. And the way we've accomplished that modern day is through automation, right? And again, infrastructure as code. So if you're Ansible, you're Terraform, you're aligned to a hyperscaler's automation strategy, whatever it is, it's really there to start with a single source of truth, commit that source of truth, and it makes its way through your pipeline in a very sustainable, repeatable, and consistent way. And we kind of accidentally discovered not only does that help us speed up, it actually helps us with quality improvement significantly. We simultaneously, over the last few years, have kind of understood this shift left mindset, which is don't let security be way down at the end of your pipeline. It's at the beginning of your pipeline. We've done the same thing with open telemetry SDKs being injected in your source code so that you can get metrics, events, logging, tracing right out of your code the day that you commit them. And so we've really been focused on this. And so what we're going to talk about now is how do we leverage AI to not only facilitate the continuance of these three strategies, automate, increase speed, and increase quality, but we'll also talk about how we can leverage AI to take us to the next level, which is really reduce the friction of operations. So if we take a look at a very generic looking pipeline where you have an individual that is committing code or some sort of an artifact into a system that goes into a source control repository. You have something that's watching that repository like a continuous integration systems. When we see that, we trigger a job, we trigger test, we trigger builds and so forth. Then if we're allowing the system to do so because it's passed all of its testing, we will turn on the CD part of that continuous deployment part, where we target those artifacts towards a specific runtime, Kubernetes, virtual machines, whatever it might be. Now, for many of you, that actually may be where it stops, right? That's the end of your pipeline. But for some folks that are now going to use those artifacts from that particular runtime, and you want to now turn that around and aim it towards an automation stack, an Ansible playbook gets built. Whatever it is, you can turn that around and again, go through this system one more time and aim it at a brand new target. So a great brownfield implementation for getting AI into that existing system is utilizing something called Model Context Protocol. So how many people have heard of Model Context Protocol? So a few folks. So no matter where you go in Cisco Live this week, you're going to hear MCP a lot. So get used to hearing MCP as much as you're hearing the term AI. It is really revolutionizing the ops and the development environment. We're going to talk quite a bit about it. But to generally kind of introduce this, what Model Context Protocol is allowing you to do is act as a proxy or a gateway between your AI world that you're now trying to grab a hold of and your existing environment, your APIs, your file systems, your databases, your Git repositories. And we want to be able to go in and leverage MCP without having to refactor or upgrade all of the native systems that we already have in place. And so we might have a situation here where we've got GitHub Copilot, we're running Cursor, we're running Claude, we're running whatever it is that you've got. It could even be a chat interface like we have in Circuit that Sujitha talked about, but anything that can light up the MCP client and talk to these individual MCP servers. And so an example that we have here is that we've got an MCP server in place for each one of our pipeline assets. So GitHub, it could be Jenkins, it could be Circle CI, it could be Argo CD in this case, Kubernetes, Ansible, et cetera, and even Cisco has MCP servers. And this allows you to not go in and try to AIify, that's a term I just made up, but basically add AI into a completely brownfield pipeline, but yet get all of the advantages of gathering information from those systems through AI and through MCP, and then turning around, and if you allow the system to, take action against those. Now, if we go through and look at this particular system, and then we also want to add observability into that from day zero so that we can actually track, are the things I'm doing with AI meaningful? Do they give me the correct metrics? Can I control things? Maybe I've got guardrails that are really not implemented properly. If you're in your IDE, you want to implement things like rules so that we can ensure that the agents that are acting with MCP are not going out and building new things that we don't know about, right? And so observability is key there. So once we've got this in place, we now have kind of a gateway drug in place for us to go to a full agentic ops environment, which Sujith is going to talk about. But when we implement these, we can now start to sprinkle in agents that are not necessarily human, but they're autonomous or semi-autonomous, where we now have source control agents. We've got pipeline agents of a variety. And these agents now, instead of just humans, we've got agents that are now interacting directly with these MCP servers under the correct conditions. And then the final part here is to kind of connect the glue of the shift left model, and that is that we implemented observability early in the pipeline, we implemented security early in the pipeline, but we want to not forget that we've actually did those things in place, and we want to be able to have AI watch those as well. And so we want to go in and implement observability, security, and compliance agents for that. And so my group within DevNet, we're running a multitude of active agents. So when you go to developer.cisco.com for all of your API needs, or if you go into developer.com Cisco code exchange, we now have a list of MCP servers and AI agents, and more of those are going to be coming out as each of the business units produce those agents and servers. And you'll be able to actually grab those, test them in our environment, and then go and implement those in your production environment. So that's a little bit of a taste of if you're right now in a pipeline and you want to start slowly rolling AI into your operations view and grow that to an agentic ops over time. Now, Sujit's going to come up here, and he's actually going to talk about a completely AI native greenfield implementation of all of these things.
Thank you, Shannon. So Circuit is an app like ChatGPT or Gemini, but custom tailored for Cisco employees. I'll give a quick demo of what this tool can do. As you can see, employees have the ability to select one of the leading LLM models, whether it's GPT, Gemini, Anthropic. It has got a default orchestration mode where, given the prompt, it intelligently routes it to the right agent. It has got access to web data so that LLMs can be grounded on web data. You can do deep research. It can do deep research on web data as well as on internal data. You don't get that with ChatGPT or Gemini. It has got an integrated agent registry where all the agents across enterprise are registered within this central enterprise AI registry. You can see connectors, which is essentially MCP servers. You can upload files. You can upload images, CSV, Excel files, etc. We have a prompt library that is built into Circuit where employees can share prompts with others. Prompts can be personal. They can be shared with teams or organization-wide. There is a built-in prompt optimizer embedded into Circuit as well. There is an option to search on history, and you can bring your own data into Circuit via OneDrive. So we essentially enable a RAG on the content that we index from the OneDrive per user, and users can create so many projects. Now, these projects behind the scenes also created as MCP servers that you can use in the agent creation as well, which I'll talk about now. So this is an agent hub. Within an agent hub, it lists all the agents and the MCP servers, like what Shannon talked about, that you have access to based on the entitlement that has been registered during the registration time. You can register an agent, or you can register a connector that is an MCP server. Again, agents and MCP servers can be shared with, it can be personal, it can be shared with teams or organization-wide as well. And these agents can be hosted anywhere, on-premise or accessible from the cloud as well. So this is a agent studio. It is like Replit. You can wipe code AI agents on the fly. All you need is provide the requirements on the agents, and it integrates to all the MCP servers that are there in the MCP registry, and you can see the workflow. You can chat against it as well. There is an option to create images and video as well. We use Google Veo 3.1 model for this. And we have a limited release, alpha release for a super agent, which is open to a few employees alone, which allows you to connect to Outlook and WebEx data. You can chat against it. You can do something very similar to personal intelligence of Google or Moldbot, etc. Now, Circuit has become the #1 used AI tool at Cisco. We have more than 100,000 users using this tool, and we get on average 125,000 user prompts per day. And you can see users have reported a high degree of productivity with this. So here are all the LLMs models that are available for employees. We can see that end of this month, we are rolling out in integration with models running on Cisco AI pods as well. It is indeed hosted on across 6 S200s deployed across 2 regions within Cisco on-prem. So if you had to implement something similar within your own enterprise, here are the fundamental architecture layers that you need to have. Like on the left side, you see LLM observability layer, which includes monitoring, metrics, auditing, etc. Then you have FinOps. If you provide API as a service, you need to have the token usage calculated per client so that you can do a charge back to them. You need to have model hosting or model API layer, capacity management to make sure that when you have enough capacity, TPM capacity for each of the models, so that you have enough capacity to serve all the API clients as well as your assistant needs. We have built-in orchestration, as I talked about, so that when a user puts in a prompt, they don't need to know which agent to route it to. We intelligently route the user to the right prompts. And the next set of layers is the platform architecture, particularly for Circuit, where you have a UI and app services. We have agentic services. We have MCP services, the search engine layer. We have AI-ready data layer and the data stores to support those APIs. And finally, we have the ingestion layer to be able to push all the unstructured data within the enterprise into our ecosystem. On the right-hand side, you see security layer, where there is integration with Cisco AI Defense, guardrails, PI detection, secure search, etc. And there is integration to the external databases or vendor tools, or even remotely hosted MCP servers or agents. I'll be focusing on 3 topics, 3 as-a-service offerings: LLM as a service, RAG as a service, and agent as a service. So employees within Cisco has got access to pretty much all the API, all the LLMs that you saw in Circuit UI. They can access it through an API. The idea behind it is they can use this API to create GenAI agents and deploy these agents within their own embedded apps. So we have a free tier. This enables employees to create GenAI apps, innovate on it, get it ready for production, and once it is ready, they can migrate to a premium tier where there are no limits. Of course, with free tier, we have embedded a lot of rate limits. Now, what is interesting is that this is a standardized API layer, so it's easy for our employees to switch between a Gemini model or an Anthropic model by just changing the model ID within the API. And of course, we have our own gateway for rate throttling. Our API does token-based rate throttling as well as request-based rate throttling as well. We have an API portal where users can see the cost usage, and there's an API for metrics, etc. So here are some of the stats from both the API usage as well as the Cisco Assistant, Circuit Assistant usage. Last 1 year, we received 325 million LLM requests that led to processing of 1.45 trillion tokens, including prompt and completion and the embedding tokens. There are around 6,200 teams across Cisco utilizing this service. And you can see the scale at which we operate. So we implemented RAG within Circuit UI, which allows users to do RAG on all of Cisco's unstructured data. So one of the things that we're trying to see is we've done a lot of optimization within the RAG system. How do we take in all of this optimization and provide it as a service offering across teams within Cisco so that they don't have to reinvent the wheel? So there are a couple of stages in which we implement this RAG onboarding process. Like one, the user goes to the API portal, they put in the information on the AI use case and the volume of the data they want to do RAG on. And then there is an automation job that kicks in to provide all the infrastructure components that needs to be created to enable this ingestion. And then finally, the user gets the details, they do the content ingestion, and then there is an API to actually do the RAG on it. I'll go into some of the details on those. So here are the infrastructure components that automatically gets provisioned. So we store, as soon as information is registered in the portal, that gets stored in Bigtable. We use Bigtable because of the low latency and high availability across the different regions. This is implemented across US and Asia and multiple regions GCP. And we kickstart the automation process for creation of Okta secrets. We use the Google Deployment Manager to enable the automated creation of Google Cloud Storage buckets, pops up topics, the service accounts associated with it. And we kickstart automated process to create indices in Elasticsearch clusters. And it might be routed to different Elasticsearch clusters based on the volume of the data that is being specified. We use Elasticsearch for our keyword search. And we use Pinecone serverless as a vector database. And we also create a namespace in the Pinecone vector database for the semantic content. And then there's a bunch of microservices that gets provisioned per client to enable the processing of all of these. And ultimately, the user gets notified of the API documentation, the credentials, and the endpoints, etc. Let me walk through the flow of RAG implementation using our agentic RAG. We use LangGraph for the RAG implementation. So when the prompt comes into a RAG API, the agent first uses the LLM to create SEO queries, multiple SEO queries from the prompt, and each of these queries are sent in parallel to both the keyword search engine as well as the vector database search engine. And the results from both the chunks goes through a re-ranking process using a neural re-ranker, which are deployed on a microservice, which is attached to a L4 GPU node in GCP. And then there's one more level of re-ranking from all the chunks received from all the top results from each of the parallel queries. And finally, the best chunks goes to the LLM to generate the final answer. We use GPT-4.1 Mini because of the low latency. We get around 4 to 6 seconds time to first token. So you can see this is the microservice view of just what I talked about. You can see that we are using an IDP to protect our endpoint. It goes through API gateways, APG, and talks to the variety of microservices, talks to the search engines. And finally, every prompt, every data point that led to a final answer is audited. It's sent via PubSub and gets stored in BigQuery, which is used for our debugging purposes. Now let me talk about the content ingestion process. So here, users have an ability to generate a token, a service token, a short-lived token. Using that token, they can upload the content into Google Cloud Storage bucket, and the reference URL of the Google Cloud Storage bucket gets sent to PubSub. And finally, there are microservices which reads from the PubSub and processes the documents for things like text extraction, chunking of the documents, embedding generation, and finally they get indexed into both Elasticsearch and Pinecone. Now, again, just like search, all of this data is 100% audited. There is end-to-end traceability for every document that passes through the system, and every microservice that touches it, there is an audit event sent. So you can easily query BQ to see what happened to a particular document. The third one I want to talk about is agent as a service. This is something we recently rolled out. As I mentioned earlier, as you've seen earlier in the demo, this is a no-code agentic tool where, just like Replit, you specify the requirement for creating agents. And it goes through multiple-step process of interviewing you to figure out what your requirements are, clarifying the requirements, and then finally, when it's got the requirements done, it goes to the next step. There is a design phase where it shows you the LangGraph architecture, and once you accept it, it goes through the code generation process, and there is an automated code review that happens using another agent, and goes if there are errors, and it fixes it automatically, and finally gets deployed. The clean code gets deployed into GCP. So as you can see, there is a way to visualize the LangGraph nodes, and then there is a way to chat against it as well. Now, what this enables is anyone can create an agent utilizing all the tools in the MCP servers that are connected to our MCP registry. So imagine if all the MCP servers in the enterprise are registered in one registry, this could open up a lot of innovation within your company. Now, we also have integrated Langsmith into the system, where there's a debug mode. What this offers is traceability, LLM traceability, to see for all the calls that happen during the agent execution, you can see and look at the integrated self-hosted Langsmith implementation within our ecosystem as well. Now, let me talk about the architecture that supports this ecosystem. Pretty much the entire ecosystem is built on GCP, and we have deployed in multiple regions, US and Asia, and these are all microservices, and they are added to an Anthos service mesh so that we have failover and fault tolerance across the different regions. Now, on the right-hand side, you see our connectors, which pulls in data from the data sources within the enterprise. And that could be on-premise, it could be accessed from the cloud as well. So we have standardized all of our connectors as Apache Spark jobs. We have our own on-prem Kubernetes cluster, where we run Spark as using a Spark operator, and the content gets uploaded to GCS, and the reference URL gets sent to PubSub, which gets processed in the cloud. Now, if the content is available accessible from the Google Cloud, we use the Google Data Proc to run the jobs. And for some use cases, we use Google Data Flow for doing data processing as well. Next, you see the ingestion services, which talks to the search engines. And then you have the retrieval services, which again queries the search. And you have the AI agents. We have multiple AI agents in the system. We have a PowerPoint agent where users can export a conversation as a PowerPoint using Cisco's own PowerPoint templates, where Cisco-approved brand images are embedded into it. We have deep research agents, like we saw earlier. We have data analysis agents, which generates code on the fly on CSV in the Excel sheet that gets uploaded. And finally, we have the Agent Studio agent as well. Now we have administration services in the portal, API portal for managing the APIs. We have approvals for MCPs and agents gets registered within the ecosystem. We have the agent registry services, MCP services, and the LLM as a service, RAG as a service, like just what we saw. And we have circuit-specific APIs. Pretty much for all the features that you saw in Circuit UI, you have an equivalent API service, and they're all backed by the data stores that you see above. So we have our own version of LangGraph checkpoint store, which we build on top of Bigtable, and we have our own conversation store, agent store, registry, all based on Bigtable. And we use APG as a gateway, and we use BigQuery for all the auditing purposes. Down below, you have AI defense for all of our security needs pertaining to the LLM. We connect to Cisco's own deep network model as well, along with the rest of the LLMs. And we have connectivity to on-prem so that wherever the agent is hosted, whether it's on-premise or not, we have a seamless connectivity to be able to securely connect to an agent or MCP server that's running on-premise. To summarize, so you should treat tools within MCP servers and the AI agents as software itself. Like, if you have high-quality API documentation, it's pretty easy to create MCP servers. One of the things that you saw in a super agent, we were using apps like Cloud Core or Codex to easily wipe code MCP servers. All we had to do is specify the API documentation URL, API details, and it could take an existing Git repository and create the tools dynamically. It's so easy. The models right now are pretty good enough to wipe code MCP servers as well. In fact, that is one of the things that we're working on to see how do we make it easy for employees to create MCP servers by just specifying the API documentation API endpoint as well. Now, there are a couple of things that you should focus on if you want to enable true automation in the enterprise. One, you need to make sure you have AI-ready data that is AI-ready within the enterprise. Two, you need to make sure there is an MCP interface for all the tools that are our APIs that is used within the enterprise. And then the idea is that you can bring in those MCP servers to a super agent or an agent in an agent studio just like you saw, so that they can talk to each other, agents can talk to each other and build upon each other. And that leads to exponential amount of innovation within your company. We have more about this in the Cisco DevNet zone over here. I have a session detailing on the features of Circuit as well, Thursday morning, 8:45 in the morning over here in one of the breakout sessions. We have a Circuit booth right at the end of this hall. You can search in the Cisco Events app. You can search for Cisco Circuit. You can get it. We are more than happy to answer questions. I have my Circuit team over here as well. Thank you.